Whether it's extracting sections, titles, subtitles, tables, images, graphs, or even formulas, handling documents with intricate layouts is no easy feat. Tools like PyPDF, PDF Miner, PDF Plumber, and even cloud provider solutions like Amazon Tesseract have been popular choices for handling PDFs, but they often fall short when it comes to complex documents with varied structures. They can handle basic extraction, but when you're dealing with intricate layouts or mixed content, they might not give you the comprehensive solution you need. That's where our Spotlight tool comes in, Unstructured.io. In today's video, we'll be exploring how Unstructured.io stands out by providing an all-in-one solution for processing and extracting information from complex documents. From understanding intricate layouts to accurately capturing every element, Unstructured.io tackles challenges that most other tools struggle with and is also recommended by some of the biggest players in AI today. We'll break down how Unstructured.io can revolutionize your approach to OCR and data extraction. Let's get started. As the first in a series of tutorials that will be dedicated to Unstructured.io, today's session will be about the Unstructured Serverless API. In future sessions, we will introduce the open-source Python library and the usage of custom Hugging Face models for layout analysis and OCR. To use the Unstructured Serverless API, the first step is to install the relevant Python package, which is Unstructured Client. We do this by running pip install unstructured-client. It is recommended to do this in a separate Python environment in order to avoid dependency conflicts. To do this, you can follow our tutorial on how to launch Jupyter Notebooks within virtual environments, which will be linked in the description. Once the installation is complete, the next step is to acquire your Unstructured.io API key. You can get one for free in two different ways. On the one hand, you can get a 14-day trial period with a free API key to process up to 1,000 pages per day. You can do this by following this link, which you'll find in the description. Click on Get Started for free and log in with your Google or GitHub account. You will land in this page where you can find your API key and a bunch of information related to your API usage. You can see I have 5 days left of free trial, but it's 14 days in total, and this is for 1,000 pages per day. Of course, you can later add a payment method to fully use the API once your trial period is over, and you can also track your billing and API usage on this page. Finally, you can generate your own API key, which we called test for the purposes of this tutorial, and you'll have the option to either copy the API key alone or get a whole Python, TypeScript, or curl snippet to call the API along with your API key. The second option is to directly get a free API key, which isn't restricted to a trial period, but allows for a much more limited usage of 1,000 pages per month. You can do this by clicking on this link, which again you'll find in the description, and once you land on this page, all you have to do is fill in your first name, last name, email, and a random company name. You will then receive the free API key by email. An important thing to note here is that one of the conditions to obtain this API key for free is that your data will be stored and used for model training purposes, so make sure you only use your free API key with non-sensitive documents. Now that we have our free API key, we can start interacting with the Unstructured API. We start by setting up our Unstructured client and preparing our document for processing. So, we first import the necessary modules from the Unstructured client package. We then define the file path of the document we want to process. For this tutorial, we will process the Attention is All You Need paper from 2017. Next, we define the Unstructured client by entering the free API key we just collected, along with the server URL, which is api.unstructuredapp.io. Finally, we open our file, read its contents, and store them in a shared .files object from the Unstructured package. Now that all the preparations have been made, we can finally send our first request to the Unstructured API. The relevant documentation is available on this link, which you'll find in the description. It features all kinds of tutorials, examples, and detailed documentation for both the Serverless API and the open-source package, from installation to advanced usage. You can check out all the modules and features provided by Unstructured.io with detailed explanations on the roles and different values of each parameter. Going back to the tutorial, we will start by sending the most basic request to the API, where the only parameter is the actual file we want to process. Once we define our request, we can send it to the API using the unstructured client and get the results back in the form of a dictionary. Let's check out what the elements of the output dictionary look like. So we can see this first element is of type narrative text, has a unique id, a bunch of metadata, and a text element. We can see the text corresponds to this first small paragraph written at the very beginning of our document. Next, let's see what are the types of elements returned in the response. We have footer, formula, header, image, narrative text, page number, table, title, and a last type for uncategorized text. Let's see what an image element looks like. We can see it has roughly the same structure as the narrative text, with a text key displaying the textual elements extracted from the image through OCR. We'll see in the following section of this tutorial how to get the actual PNG image extracted as well, which can be very interesting. For example, if we want to use a multi-modal LLM to directly take the image as input. Finally, let's take another random narrative text element to get a clearer idea of what they correspond to. We can see that the text component here is a bit larger and actually corresponds to this paragraph right here, which is the second paragraph of the introduction. This leads us to the idea of layout-aware chunking, which is a smart form of chunking that takes into consideration not only the target or maximum size allowed for a chunk, but also the general structure of the document, its sections, subsections, and so on. It allows for coherent and complete chunks, meaning, for example, that a chunk won't contain two different subsections, and that a section that is split by a new page will be merged into a single chunk. You can check out the documentation specific to this concept through this link, which again you'll find in the description. It displays 4 different chunking methods, including basic chunking, which is the most common one depending only on the target and maximum sizes in characters or tokens, chunking by title, which takes into consideration the partition of the document into sections and subsections, as well as other methods, such as by page and by similarity, which you can check out in the documentation. For this tutorial, we will try out the by title method with a constraint of 1,500 characters as a maximum chunk size. Let's check out the chunks obtained with this request. So we can see the chunks are now larger since we allowed for up to 1,500 characters, but they're also coherent, corresponding to specific sections of the document. For example, the first chunk includes the preamble, title, and authors of the paper. The second chunk is the abstract, and the third chunk is the paragraph about contributions. The introduction is spread into 2 chunks, each containing 2 complete paragraphs, in order to respect the chunk size limit, and so on, for the rest of the document. Visually, we can see that each chunk constitutes a complete and coherent unit, respecting the size constraints, while at the same time taking into account the layout of the document. In the final section of this tutorial, we will see how to extract the entire images or tables from the document as visual elements, instead of simply getting their text through OCR. We start by importing the pillow and matplotlib packages, which we will use to display the images. Next, we define the parameters of our request, this time by setting the strategy parameter to high resolution, which is not necessary, but improves results at the cost of more latency, and by setting extract image block types to this list, which is stating that we want image and table elements to be extracted as visual elements. Let's now check out the results. Again, we display a random image element from the response dictionary, and we can see it has a different structure from before, this time including an image base64 key, which contains the entire image encoded in base64 format. This is perfect for a multi-modal LLM, since it takes images as input specifically in this format, as we will see in future tutorials about RAG. Now, in order to visualize the extract images, we use this for loop, which will start by decoding the base64 image, then convert it to bytes, and finally, read the bytes object to get an image that we can plot with matplotlib. As you can see, we get the entire images extracted as they are in the document. And of course, we can do the same with tables. A table element will have the same image base64 key contained the encoded table, and we can display all the tables using the same for loop. That's it for today's tutorial, which was an introduction to UnstructuredIO, specifically to its serverless API service. Our next Unstructured tutorial will tackle the open source version and explore some customizations with Hugging Face models of our choice. Don't forget to like and subscribe to the channel if you appreciate the content, and I'll see you in the next video. Bye-bye!